So now we miss only one ingredient to draw the real perfect cube. We already know how to draw boxes, and the only thing missing is making sure that all of these sides of the box are equal. Well, essentially it is a problem with measuring in perspective. So we have some point, we have a line which moves to some vanishing point, and we want to, for example, decide that this segment is 1 meter, and we want to make sure that we can mark a segment there, or there, which would be equal to 1 meter as well. But well, we know that during perspective projection, length are usually reduced, so we could figure out that it should be one of these ones. But which exactly is 1 meter long is impossible to figure out, at least with the lack of information. To make it precise, we again need to study geometry a bit and look at the following picture. We again have a picture plane. We again have a viewer position. Viewer looks at the viewer direction, which we associate with the point of projection of viewer position to picture plane. And then we have some line, like here. Let's define the point of origin. And for example, it goes into this direction and goes slightly up. So we have this kind of line. Okay, so we can select some point and decide that it will be a start of the line. We can use definition of vanishing point to construct the vanishing point itself. So we have somewhere there, it's again not really precise because it's a sketch. We have somewhere there the vanishing point. We connect vanishing point with the point of origin and we will get a projection. And now we can say that this segment, green segment, well, not this segment, I guess, we want to, well, okay, we will take this segment and say that it is 1 meter long. And we want to use our inspiration, view direction, picture plane, to estimate, to draw where exactly 1 meter will be placed in perspective. So we can move this 1 meter back to the image, to the bold space. Let's say that it's somewhere there. Well, we can draw it more precisely, of course. So we have 1 meter long line there. And we want to move this line, this length, to the red line, which goes indefinitely toward vanishing point. So how are we doing it? We do it in the following way. Imagine that we already decided where this point is. Let's figure out the properties. For example, if this line is there, well, we can connect end of this segment with this imaginary point, which we figure it out, and get some triangle. Let's fill it with color. And we have another line which goes indefinitely, and again we can draw for this line some vanishing point. So it goes in this direction. We draw a parallel line, and we get this triangle, which is parallel to the triangle in the original triangle in the world space. Let's fill it with color as well to show that it is a triangle which is parallel to the initial triangle. So this will be, this line is parallel to the red line. Let's show that this line is parallel to the blue line. This is line A, B. This is vanishing point B. This is vanishing point A. So we have two parallel triangles, which are actually similar triangles. Why? Because this black line, which we say that it is a horizon line for AB, is parallel to this green line by construction of our horizon, just by construction, because we constructed this green line as a parallel line to the picture plane. So let's just do it precisely. We already decided direction of the green line there, which is purely horizontal direction. And then we decided to use this line to form another plane. And all these lines will be going into direction like this. And during construction of this vanishing point, we could just use this plane. We could just move it toward this viewer position and obtain the intersection, which will be just a shifted position of this green line. It's not a precise proof, of course, but it allows us to understand that they are actually parallel, this line and this line. So they are parallel, and we have some angle here, which is equal to this angle. We have angle there, which is equal to this angle. And as we assumed that this segment is equal to this segment, we see that this triangle have two equal sides. So from geometry we know that there are two equal angles, and there are two equal angles as well. And we know as this triangle is just similar to this triangle, so there is an equality of sides as well. And if we, for example, if we knew this point, red point, this point, if we already knew this point, then we, would be able to construct a blue line. if we have image, this image, so to draw a blue line, we could projection of blue line. Well, not projection, because, well, yes, projection. We just use draw this line, and we can see that the projection of intersection of blue and red line, let's show it with a very neon blue, they will be at the same place as we could expect. So we could say that this segment and this segment display equal length, because they are projections of something which have equal length. So if you had this red dot, red point, we could draw this green line and connect this free floating side end of this segment with the red vanishing point and obtain the required length of our original line, drawing on our original line. This is how it works theoretically. But of course, when we are drawing, we do not have a three-dimensional space, because otherwise it would be very easy and we would be doing 3D modeling. So what we are doing is the following. We again use station point construction. We rotate our viewer position to our picture plane and obtain this triangle, but it is not in the three-dimensional space. This triangle will be on the picture plane, on our actual drawing. So we start with the following. Again, there is our new direction. There is some line which we want to draw with a given distance. We selected some distance, assuming that this distance is 1 meter long. There is some vanishing point. Now we can draw the horizon line parallel to this selected distance. And use this horizon line to draw a station point relative to it. So when we are drawing this station point, we again effectively deciding on the distance of viewing position to the picture plane. So for example, we have station point here. Then we could connect it like this, draw an orthogonal line, obtain vanishing point 2, which is not needed, but we could do it. So we currently need only station point, and we need this distance. Next, what we are doing next? Next, we are drawing this triangle. How are we drawing this triangle? We notice that this side is equal to this side as well, because it is just a rotation of this triangle. So we have this side, and we want to obtain the similar side on this line, on the horizon line. Well, if you have some ruler or some other way to measure equal distances, for example, you can draw circles, then you could do it precisely, but usually it doesn't really matter. You can just do it in a really raw way. Just draw something which resembles a segment of circle, some arc like this. It will be usually enough for practical purposes, but remember that these segments, let's draw them again in the same column. This segment should be equal to this segment. And now we obtained this vanishing point B, which is usually called a measuring point. Well, you can, for example, say that it is a measuring point 1. And finally, we can use this 1 meter long line. Well, let's make it shorter, so it doesn't seems to be connecting with this line. Well, let's just erase this line so it doesn't mess with our perception, because it was not needed actually in our construction. And now we can just draw a line toward our vanishing point, measuring vanishing point, and obtain the required triangle, this triangle. This is the core idea of measuring points. So we have there 1 meter long line, and this is a projection of 1 meter long line. You can do it with any length. You can do it into the other direction as well. For example, you can say that, well, you can measure there something like 1.5 meter, and you can use the same measuring point to draw there 1.5 meter long line, a projection of 1.5 meter long line. This is how it works. So this is not the easiest construction to understand, but it unlocks us an ability to draw rectangles. Well, not even rectangles. It allows us to turn rectangles into squares and boxes into perfect cubes, which we'll discuss next time.